All right, guys. So here's this again, totally optional. If you did this problem, I think it'll only help. I'm not requiring you to view the video, but I will post it in Classroom so you could go over it. So here's this other example, and like Katie had asked in class, I will be specific as far as the question on the quiz. Like I'll give you the scenario, and then I'll say, all right, make a tree diagram. So you can differentiate between when to do this as opposed to a Venn diagram. But here we're told the company has developed a program, to detect steroid use by athletes. We're given some data here that the test is accurate 95% of the time when the athlete does in fact take steroids. And we're also told that it's accurate 97% of the time when the athlete does not take steroids. Okay. Suppose that the drug test will be used in a population of athletes in which 10% have actually taken steroids. Okay. Let's choose an athlete at random, and we administer a drug test. So here's our tree diagram, right? So we'll start with, here's our athlete. And the first set of branches, prior to the test being positive or negative, the first set of branches would have to be, well, do they take steroids? Where's that essay? There we go. Or, do they not? I spelled that wrong. All right. Now, from there, you can worry about the result of the test. Is it a positive test or is it a negative test? And the same down here. Even though they didn't take steroids, there still is a small chance of what would be called a false positive, all right, or a negative. So again, suppose the drug test is used in a population of athletes, which 10% have taken steroids, which means 90% do not. The test is accurate 95% of the time when the athlete does. So this would be 0.95, and then 1 minus 0.95 would be this number here. Let's say it's 97% accurate when an athlete has not taken steroids. So, no steroids, for that test to be accurate, that would mean the test comes up negative, which would give us this number as 0.03. So that's part A, okay? B is, what is the probability that this athlete tests positive? Well, there's two ways to test positive, right? There's two sets of branches in which that positive result could happen. You can't just add up those numbers. You have to get to that positive, right? We have to get to this branch, get all the way out here. And to do that, we'd have to multiply. We'd have to say, all right, well, it's going to be the probability of, I'm just going to abbreviate, so I'll put an S, for steroids and a positive test, right? Plus the probability of that false positive, which would mean no steroids and a positive test. So to do that, 0.10 times 0.95 plus 0.9 times 0.03. All right, so let's take a minute, punch that in your calculators. And we should get 0.095 plus 0.027. And that should give us our answer of 0.122. If you want to make it a percentage, you could. Both would be accepted. All right. Now, suppose the athlete has tested positive. In other words, given there's been a positive test. What's the probability that they actually took steroids? So steroids given a positive test. All right, that's what we're being asked to find. And again, I'll give you the formula. And if you wanted to write it out, it would be steroids and positive test divided by a positive test. All right, and that's what we found in part B. Part B was the probability of a positive test. So our denominator we already found. We actually also found the numerator, as it was a component of us getting our answer in part B. All right, so 0.095 divided by 0.122. And that makes sense to get a high number here, right? So 0.779. So about a 78% chance that given it was a positive test, that person actually took steroids. All right, so that could be a little bit alarming to you, right? Meaning, look, there still is a pretty big chance that you didn't do it, right? So there is a chance that, okay, you did test positive, but an over 20% chance that, yeah, you know what, it was a false positive. You actually did not take steroids. So hopefully that helps. Shoot me an email if you have any more questions. All right, guys. But I think that'll give you a better idea of what to expect as far as this problem. All right. Enjoy your weekends.